Okay, since I'm not there, I'm going to just send you this these slides with a mini tutorial. It's not the most exciting way of teaching, but I'll try my best and see how we go. So, first, apologies for not being there, but we'll see. I'll try and do my best with this. Okay, so what you need to do is listen to this a couple of times and copy down the notes into your theory books. Now, some of this stuff should be revision from last year, but if it's not, make sure that you go through these notes a couple of times and until it all makes sense. Alright, so let's start with the trig ratios. And you already know these. Now there's a little bit of background noise. We'll see how we go. Or maybe not. Alright, here we go. Alright, so let's just draw a right angle triangle. Hang on. And I'll just go this way here. There's my right angle. Now, as it tells you there, the hypotenuse is the longest side, always opposite the right angle. So we know that this is the hypotenuse. Okay, and if I mark an angle, let's call this angle theta down here. Okay, the side opposite is over here, so the opposite side is there, and adjacent means right next to, so obviously this is the adjacent side. Okay, as I said, this should be a revision, but if you didn't know this, you can now make some notes or copy these down into your theory books. Now, looking at the trig ratios here, we have sine, cos and tan. So remember, sine is opposite over hypotenuse, cos is adjacent on hypotenuse, and tan is opposite over adjacent. And to always remember these. So we're back. So the trig ratios, and if you remember, hang on, I won't be able to write on this. Okay, never mind. Sokotoa, just write it on the side somewhere when you take down your these notes. Now, as well as sine, cos and tan, we have the inverse ratios. Cosec, sec and cot. And all it is, it's just the inverse ratios of the ones that we have at the top. Now remember, a ratio is a comparison between two sides. So here we're comparing sides in right angle triangles. So that's what this is all about. That's what we're doing in trigonometry. Now, cosec is cosecant, sec is secant, and cot is the cotangent. And cosec is 1 over sine, sec is 1 over cos, and cot is 1 over tan. Alright, so if we go to the... Yep, now we've got examples, but before I do that, I just want to write down... So... hang on. Can't spell. Alright. Okay, going back. So, Tower. Alright. And the opposite of sine is cosec. The opposite of cos is sec. And the opposite of tan is cot. Now to remember this, look at the third letter of each of these. So 1, 2, 3, third letter S. 1, 2, 3, third letter C for cos. And the third letter here, 1, 2, 3, T for tan. Okay? So these are the inverse ratios. of sine, cos, and tan. Okay, now looking at the example here, it says if sine A equals 2/7, that's a fraction, find the exact ratios of cos A, tan A, and cot A. So the first thing that we do is we draw a right angle triangle. Okay, and I'm going to call this angle here angle A. Okay, that's that angle A. Now, we know that sine A is opposite over hypotenuse. So the opposite side of this is 2, and the hypotenuse is 7. So because I'm asked to find cos A, which is adjacent on hypotenuse, I don't like that A, hang on, I use capital A. And tan A, which is opposite over adjacent, I need to find the adjacent side, because that's what I have. So to do that, just call that adjacent side x. We use Pythagoras Theorem. So c squared equals a squared plus b squared. Remember, my c is my hypotenuse, so 7 squared equals to 2 squared plus x squared. So that's 49. Take away 4 from 2 squared equals x squared. So then we do 49 take away 4 is equal to 45. So 45 is equal to x squared. Therefore, x is equal to the square root of 45. And we now need to be able to simplify surds. So to simplify surds, remember we find a square number that goes into 45. And that would be 9 times the square root of 5. And we know that the square root of 9 is 3, so it's 3 root 5. Okay, so now I know that x is equal to 3 root 5. That's my adjacent side. So, answering the question then, cos A is equal to adjacent, which is 3 root 5, over the hypotenuse, which is 7. Tan A is equal to opposite over adjacent, so that's 2 over 3 root 5. And finally, we need to find cot A. Now remember, cot is the inverse of tan, which is 1 over tan A. So what does that give me? Hang on, I'll just draw a little line here. 1 over tan A, so that's the reciprocal of tan, right? So that becomes 1 over 3 root 5. Now if you think about it, 1 over 3 root 5, 1 over 2 over 3 root 5 is just 3 root 5 on 2. 3 root 5 on 2. And there you have that question. Alright, so I hope you get this and just think about what you're doing and follow. I know this is not the best way of doing things, but just listen to it a couple of times if you don't get it the first time. Remember, you're using Pythagoras Theorem to find the unknown side first, and then you are looking at the trig ratios that you're asked to find and working them out. Okay, so the next one, instead of a fraction, you've got a decimal, but it's very simple again because 0.7 is the same as writing 7/10, right? So that is 7 over 10. So what are you going to do next? Okay, step number 1, draw your right angle triangle. Actually, I'm going to draw it the other way now. Okay, so you can see, well, that's not the best right angle triangle, but anyway. Now I better fix it. Hang on. Alright, here we go. Alright, so let's call this angle here angle B. Now I'm told that it's cos B equals 7/10. Alright, now cos B is equal to adjacent on hypotenuse. So adjacent side is 7, the hypotenuse is 10. Now because I'm asked to find tan B is equal to opposite over adjacent, and sine B is equal to opposite over hypotenuse, so I'm missing the opposite side. So what do I do next? Use Pythagoras' theorem. So we have, call that x again, the opposite side, or O, whatever you like. So, sorry. So x squared plus 7 squared equals 10 squared. A squared plus b squared equals c squared. So x squared is equal to 10 squared is 100, minus 7 squared is 49. That's just solving an equation. So 100 take away 49 is equal to 51. So x is equal to the square root of 51. And we can't simplify that because 51 is a prime number, so we can't divide it by anything. So there are no square numbers that are going to 51. So we leave it. And now we just answer the question. So tan B is equal to opposite over adjacent. So this is the square root of 51. So opposite is the square root of 51, and the adjacent is 7. And sine B is opposite over hypotenuse, so that the opposite side is the square root of 51 over 10. And that's it. You're done with that one. Okay, now we move on to complementary angles. Now, you don't have to, you can remember these, there are a couple of ways of doing this. You can remember this triangle, right angle triangle. Now have a look. You've got a right angle triangle, the right angle at C, angle B is theta, alright, and this angle A is 90 minus theta. Why is it 90 minus theta? Because the sum of the angles in the triangle add up to 180 degrees, so you know that that's 90, angle C is 90, that's theta. So therefore the third angle, what's left, is 90 minus theta. Alright, it's whatever is left from 180. Alright, now, and then opposite side, so opposite angle A is little a. Alright, there we go. Opposite angle C is little c. And opposite angle B is little b. Now, looking at the three angles and finding sine, cos and tan, if you think about it, sine theta is opposite over hypotenuse, so using the letters little a, little b, little c, opposite is b, hypotenuse is c, so that's how we get b on c. And then cos theta is adjacent on hypotenuse, so that's how you get little a over little c, and so on. I don't have to go through all of them, just look at the results here. Then if we look at the other angle, the angle A, the 90 minus theta, and do the same process again, so sine 90 minus theta is equal to opposite over hypotenuse, which is little a on c, and that's how we get that one. And then we go through the whole process again, and we get these results. Now, if you match up the corresponding, so if you have a look on the left hand side, so this is my, just put it over here, left hand side, and this is my right hand side results. If I match them up, look, sine theta is equal to little b over little c. Now that is the same as cos 90 minus theta, which is little b over little c. then if I look at cos theta, which is little a on little c, that is the same as sine 90 minus theta. And we can keep on going. So if I look at tan theta, which is little b on little a, it is the same as cot 90 minus theta. Sec theta little c on little a, so little c on little a is the same as cosec. Okay, and so on. You can finish that off when you have a look. So then we get the following result. There they are. So from these ratios come the following results. Getting tired. Need a bit of a break. I'm sure you do too, but keep going. Don't give up. All right. So we have sine theta equals cos 90 minus theta, cos theta equals sine 90 minus theta, and so on. So look at the pattern. Sine goes with cos. Alright, look at that. Sine goes with cos, cos with the sine. Sec goes with cosec, third letter. Cosec goes with sec, the other way around. And tan is best friends with cot, always. Alright, so they go together. Okay, so look at the pattern so that you can remember these results. Alright, then I'm going on to the next. We use those results to answer these questions. Now, the first question is simplify tan 50 degrees. That's degrees minus cot 40 degrees. Alright, so using the results from above, we can either change tan into terms of cot or cot into terms of tan. I'm just going to use tan. So using the above table from the previous slide, tan theta, if you remember, is equal to cot bracket 90 minus theta degrees. Okay, so remember I said tan is best friends with cot, so we're going to now change tan 50 therefore is equal to cot. So we're replacing theta for 50. 90 minus 50 degrees. So that gives me cot 40 degrees. So now, going back to the question which said tan 50 minus cot 40, well, now I know that tan 50 is the same as cot 40 minus cot 40. Oh, that's easy. That just equals 0. And that's the answer. Right, so the whole idea here is to either change tan or cot so that you have the same trig ratio throughout the question. Alright, that takes us to where it says simplify cos 61 degrees, there's the degrees, and plus sine 29 degrees. Well, same as before, we either change cos 61 into terms of sine or sine into terms of cos. I'm just going to start with the first one. So remembering my result, cos theta, remember, cos is best friends with sine, so that equals sine 90 minus theta. Alright, so cos 61 degrees is equal to sine 90 minus 61 degrees. Okay, so cos 61 is equal to sine 29. Alright, so there's sine 29. So now, replacing cos 61 with sine 29, I end up with... Oh, hang on, let me just rewrite this. Sorry, I need a bit of a breather. I'll do it on the side here. So, we now know that cos 61 is equal to sine 29. So I end up with sine 29 9, which is my cos 61, plus sine 29. What does that equal to? This is like algebra. It's like saying x plus x, or so if I replace sine 29 for x and sine 29 for x, I end up with 2x, right? Well, so this becomes 2 lots of sine 29, and that's my final answer. Now, the last question here, the example number 3. I now need to find the value of P if cos 49 degrees is equal to that. Again, I'm going to change cos into terms of sine. So cos 49, actually, let's write the trig result first. Cos theta is equal to sine 90 minus theta degrees. So, cos 49, so now we replace theta for 49. I end up with sine 90 minus 49. I hope this is helpful, guys, and I hope you're not wasting your time and ignoring what I'm saying here. So, I'm going to test you when I get back and see if you've actually been paying attention. So this gives me sine 41 degrees. So sine 49, sorry, take that back. Cos 49 equals sine 41. So, over here, going back to the equation of cos 49 equals sine bracket p plus 10. Don't fall asleep on me when you're listening to this. Make sure you're taking it all in. So this becomes sine 41 equals sine p plus 10. Now, because everything is in terms of sine, I forget the sign, just leave it out, and I now have the equation of 41. Actually, don't write the degrees. 41 equals p plus 10. So subtract 10 from both sides. Therefore, P is equal to 41 minus 10, which is equal to 31. And there we have it. We found the value of P. Easy. Alright, so make sure that as you go through these, you copy these into your exercise books. And maybe just listen to it once and then you do it by yourselves. I will give you the questions at the very end, the ones that I want you to do during the double period. Okay. Exact values. Alright, now if you remember from last year, remember I said that these will come back and that you needed to learn them? Well, let's see if you actually remember these. These are, you will need these for the question, I think it's questions 9 or 10 from the first exercise. Yep, 9, 10. And further, and probably 11. So, pay close attention. You're probably, if you were very good last year and you actually learned them, then you shouldn't have any issues. Okay, so let's say this is a right angle triangle with a 60-degree angle and a 30-degree angle. Alright, so 60 plus 30 is 90, plus 90 is 180, so we've got it all covered. And the longest side is 2, the hypotenuse, and this is 1. And the side that's missing, using Pythagoras' theorem, let's say that's x again. I like just using x. So I end up with Pythagoras' theorem, c squared equals a squared plus b squared. So 2 squared is equal to x squared plus 1 squared. So that's 4 minus 1 equals x squared. So x is equal to the square root of 3. Okay, so now let's start with sine 30. These are my exact results. Cos 30, tan 30. Remember these? Now, I'm sure that Patrick, I think John also would remember some of them. And the girls, Pia, Emily. Alright, let's see how we go. Sine 30. that's opposite over hypotenuse. So from sine, opposite is 1, hypotenuse is 2, so sine 30 is a half. Cos 30, adjacent on hypotenuse, root 3 on 2. And tan 30, opposite over adjacent, 1 over root 3. Okay, then we go to sine 60, cos 60, and tan 60. Alright, so now we're looking at the angle 60. So sine 60 is opposite over hypotenuse, so that's root 3 on 2. Cos 60, adjacent on hypotenuse, a half. And tan 30, opposite over adjacent, root 3 on 1, which is just root 3. Look at the patterns. Look at sine 30 and sine 60. And cos 60, sorry. Sine 30 and cos 60. Alright, see they're complementary angles, so they're the same. Anyway, just look at the patterns and learn these. You just need to learn them off by heart. Then you've got the other triangle, which is an isosceles right angle triangle. So these two sides are the same, therefore the base angles are the same. So that's 45 and that's 45. And we know that this is 1, this is 1, therefore the hypotenuse is the square root of 2. So now we have sine 45 degrees, cos 45 degrees, and tan 45 degrees. What are these equal? Sine 45, well, it doesn't matter which 45 degree angle we look at, we're still going to get the same answer. 1 over root 2, and the same for cos. And we know that tan 45 equals to 1 over 1, which is just 1. Okay, so please start going back. And if you can't remember them off by heart, just draw the right angle, these two triangles every time when you get the answers. Okay. The work that I've left for you to find an unknown side or an angle. Let's see if you this is just revision. Let's just start with find x to 1 dp using right angle trigonometry. And I'll just make it up here. This is actually, let's use our exact values. Alright, this is x, and let's say, no, that's not going to work because it's going to be too easy. Let's rub that off. Let's just say that the angle is 41 degrees. And then let's make it a little bit harder. Let's say that x is there, and this is 5. Okay, so that's opposite over hypotenuse. So that's sine, remember? So, alright, so sine 41 is equal to opposite over hypotenuse. So I want to find x. So remember, multiply both sides by x. So that gets rid of that. So I end up with x sine 41 equals 5. Divide both sides by sine 41. And then x is equal to 5 divided by sine 41. So using your calculator, make sure it's not on radians, it's in dg. So let me just see if mine is. Okay, so 5 divided by sine 41 equals 7.6 to 1 dp. Okay, and number 2, this is just revision, so to see if you're doing the if you did the questions that I left you last week correctly. Alright, now finding an angle this time. Let's say this is B angle theta. And then this is 15.5. and this is 12.9. Okay, this time I have opposite over adjacent, so that's tan. So tan theta equals 15.3 opposite over adjacent over 12.9. Now, because we're finding theta, we need to use our shift key. Alright, so the steps are, so second function, not shift, that's the old calculator. Second function, tan, and then you can use brackets, open bracket 15.3, fraction bar or divided by 12.9, close bracket, equals, and you get theta is equal to 49.8645, and it goes on and on and on and on. So I need to convert that to degrees. So I now press again second function DMS, and let's round it off to the nearest minute. So that's 49 degrees and 52 minutes. Remembering that halfway is 30 because we're talking about 60 being the whole, so halfway is 30. We get that answer. Alright, so that's the end of that. Now I'll post this on Edmodo. I know this is probably really long, but just take your time with it, make sense of it all, and then do the exercise, which is going back to the very first exercise now, 6.1, using your homework contract. Have a go at exercise 6.1. There are 20 questions, but you don't have, I know that they're not all there. Just do that, and then exercise 6.2, which I haven't given you, is just rounding off to nearest minute, nearest degree. Very simple stuff, just using the calculator. Alright, so I'll post all of that on Edmodo. So when I get back, you should all have completed the very, if I remember correctly, the first 4 exercises. Yeah, I think, no, I'll check and see what I've left you. Yep, up the first 4 exercises done. Okay, alright. And that's it from now. Good luck with your questions, like Maths Online says.